This video is an intro to logarithmic equations, its word problems, and its exponent property. To get started, the basic exponential equation is a to the power of b equals c. Now, we just convert this to log form, which is log a of c, which equals b. So, this log form allows us to solve those equations in which the variable is in the exponent of the exponential equation. So let's take number 1 for example. 3 to the power of x equals 27. So let's change this to log form. So it would be log 3 of 27 equals x. So now we can plug this into our calculator. Log 3, 27, which we can see equals 3. And if we plug this in for x, 3 to the power of 3, we know we get 27. For those calculators that don't have the change of base for the log, what we can do is log c over log a, and we should get b. So let's try this over here. So log of 27 divided by log of 3 should get us 3. So that is our answer. Let's try number 2. So log 4 of 49 equals x plus 4. Let's solve the first part of the equation, log 4 of 49. You can just plug this into our calculator. 49. So we see that this is about 2.8, but 2.8 equals x plus 4. So now we have to subtract 4, which means that x equals negative 1.9 approximately. For the last equation, what we do here is convert the log form to an exponential form. So we can take 5 to the power of 6 equals x. Again, we can just put this into our calculator, and x equals 15,625. Okay, so now we can apply this to word problems. So for the first one, the population of a city in 2020 is 16,000. It currently increases by 30% every year. When will the population be 40,000? So first, let's write a general equation for this problem. So the population of the city equals 16,000, which is the initial population in 2020, and it grows by 30% every year. So 1.3 represents a growing 30% every year to the power of x, which represents years after 2020. So this is our equation to find the population in any given year after 2020 for the city. So now what we have to do is plug in 40k into the equation. So 40,000 equals 16,000, which was the initial population, growing by 30% every year after 2020. So the first thing we have to do is divide by 16,000 on both sides. So 40,000 divided by 16,000 should be 2.5. Yep. So 2.5 equals 1.3 to the power of x. So now what we can do from here is convert this to log form. So log 1.3 of 2.5 equals x. So now we can plug this into our calculator. So log base 1.3 of 2.5 gives us about 3.5. So 3.5 years after 2020, the population will reach 40,000. So that puts us into 2023. So about halfway through 2023, the population will be 40K. So the next word problem. A disinfectant kills 70% of germs every 5 minutes. If the disinfectant is applied to a surface with 7,000 germs, theoretically, when will there be 1,000 germs remaining? First, we have to write an equation for this problem. So, the amount of germs equals the initial amount, which was 7,000, decreasing by 70% every 5 minutes. So it's x over 5 because when x is 5 minutes, the exponent will be 1, which means it will be decreasing by 70% every 5 minutes. So now since we have the equation, from here we can plug in 1,000 for germs, which equals 70,000, which is the initial amount, decreasing by 70% every 5 minutes. First, we had to divide 7,000 on both sides. So that would leave us with 1 over 7 on the left side equals 0.7 to the power of x over 5. Now we can convert this into log form. So log base 0.7 of 1 over 7 equals x over 5. So now we can put this into our calculator. Log base 0.7 of 1 over 7, which is about 5.5. We can say 5.46 equals x over 5. Now we just multiply both sides by 5 to get x by itself. Multiply by 5. And we get about 27.3. So this is how long it will take for the germs to be about 1,000. So 27.3 minutes for the germs to decrease at a rate of 70% to get to 1,000 remaining. The last topic is on the exponent property of logs. So basically this says that log base of a number to any power is the same thing as that power multiplied by log base of the number. So these two are basically the same thing. All you have to do is bring that exponent out to the front. So for the first example, we can do that x over there, we can bring that out in front. So then it'll be x multiplied by log base 4 of 64 equals 9. So log base 4 of 64 equals 3. So we can combine the x and a 3. So it'll be 3x equals 9. Divide both sides by 3, and we get x equals 3. And we can check this answer by plugging in 3 into the original equation. So 64 to the third power is 262,144. And log base 4 of 64, not 64, 262,144 is 9. So we can check to make sure the solution is correct, which it is, 9. For the second example, we can bring that 5 out to the front of the equation. So 5 multiplied by log base x of 25 equals 10. So here we can bring this x over to the right, the 5 over to the right side. So we divide both sides by 5, and we are left with log base x of 25 equals 2. So now we can change this into exponential form. So we do x to the power of 2 equals 25. So to solve this, we just take the square root of both sides. So x equals square root of 25. So square root of 25 equals 5. And that is our answer. And we can check that by putting in 5 for x. So log base 5. Like first, let's do 25 to the power of 5, which is that number. And log base 5. Log base 5 to log base 5 of that number is 10. And so we know that is correct.